the area of a triangle in non-right angled trigonometry. I'll very briefly go through how we get the area formula and then two ways to use it. So we've got here a standard non-right angled triangle, and as we usually do, if we drop a line perpendicular to AC, giving us a right angled triangle here at point P, if we just look at that triangle, you don't actually need to redraw it, but it's up to you. So this triangle here, we let this be H, of course. Then if we get sine of angle C, that's H over A, the height opposite here, A is our hypotenuse, so moving A to here, H is A sine C. If we look back at this triangle, we've now found the height of the triangle that's perpendicular to the base. And as you know, the area of a triangle is half base times height. That's half times, the base here is B, quite usefully. And the height we just worked out was A sine C. And so if we just rearrange that very slightly, our area is half A B sine C. Sorry, should have had a capital C there. Half times side A times side B times the sine of angle C. Now, what that says is that to use this formula, I need two sides, A and B, and you'll see that A and B, the angle in between them, is side C. Angle C, so I need two sides and the included angle. This is our area formula. This is the one that you need to know and use, and it needs two sides and the included angle. So two types of questions that we might get. We might just have to find the angle. You might be at the stage where you can get away with not labeling a triangle that's as simple as this, because you know you need two sides and the included angle. But if you are at all likely to mess up in any way, make the two sides A and B, make the angle C, if you can get away with it, of course. You basically, whatever they are, you're going to substitute the two sides into A and B and the angle into C. So that makes that angle A, that angle B, this is side C. You probably don't need to label all of this. A, B and C is enough that you can see what you're doing. I'm labeling it all, but it's often easier to just label what you've got. Write your formula. Substitute your values. And we'll get our answer. With a calculator, that's really helpful. Now I will type it all in, but you can see obviously half times 90 is like 45, so it's okay to take a shortcut. And that is 21.8. We're finding the area, so we're in centimeters squared. That's it. The other question you're likely to hit is that you're given the area and you get asked to find one of the sides. So again, label what you've got, A, B, C, that's a capital. Write your formula, substitute in your values, and we happen to know the area this time, so you'll see we're substituting in everything we know, and we've got the x there. Now everything here is multiplied together and then multiplied by x. So we divide both sides by all of that multiplied together. If you're not sure what I'm doing here, an extra line, 70 equals x times half times 11 times sine 93 degrees. There's nothing wrong with writing it like this, and then I'm going to divide both sides by this to get x on its own. We could write it like that, but chances are it's going to work out like this. And it's fine then, sorry, I'm getting a little bit messy there, fine to type that all in just as it is. 70 over 0.5 times 11 times sine of 93, and x is 12.7, and we're in centimetres. Okay, now technically in the diagram here it said x centimetres, therefore because we're finding x, I wouldn't actually put the centimetres there. I'm not fussed. If the centimetres are there and you put x centimetres here as well, I just think you're being careful with your units. I wouldn't dock a mark, but technically to be correct, that is x because they gave the units there.